Hi, my name is Rich Im, System Engineer, Cisco System. Um, Today, I would like to demonstrate the prototype that we built for reading the medical sensor over the BLE. Okay, uh, let me share my screen first. Okay, here you go. We leverage the DNA space in the cloud that managing the Wi-Fi to read the informations of the BLE. And we use the Cisco Wi-Fi and the several applications to trigger up the follow-up actions whenever there is a informations coming from the BLE sensor. My team, myself, Richim, is under Cisco system. My colleague Wayland is also under Cisco system. Ian Wang is coming from Wager Technology. The testbed architecture that we used, we have the DNA space backend and the Catalyst 9800 as a wireless LAN controller. We have the Catalyst 9100 access point to communicate with the BLE sensor. We do not have the medical vital sensor that can read the vital informations, but the actual production things that gonna to be pushed out to the e-healthcare market that we target to hospital or clinic that will read the vital informations from the patients using the vital sensor that will leverage the BLE as a communication channel. Okay, this is our testbed architecture. We have UCS server that support the virtual machine because we have the application server that is a piece of the Linux. We have the Catalyst 9800 CL as a virtual machine running on the same Cisco UCS server. We have a core switches connecting to a Catalyst 9100 access point, and we have some BLE sensor that can read, actually not read, to sense the environmental information. For example, that we can sense the humidity and the temperature just for the prototype building. We have ASA 506 firewall to support the remote access because when we were doing the development, we need some kind of the remote access. We have the AnyConnect installed in my computer for code development and remote access. We have a router that connecting to the internet. Over the internet, that we have the DNA space for the backend control and the trigger for the RESTful call to the applications that we wrote. This is the application architecture that we have. We have the DNA spray in the cloud. Whenever there is a telemetry information coming from the BLE that may over some kind of the threshold that's set up in the DNA space, it will trigger up a RESTful call into my application server. My application server actually is a piece of Linux that installed with a Apache that can support PHP as a web applications. Secondary, that my Linux can support Python script. I use the Python script to trigger up the SMS calling to my phone, to text to my phone. And I have a database to store some kind of the data. Maybe if I want to like write down the timestamp, write down the the patient's temperature or patient heartbeat, that I can record down into the backend database. I use MySQL as my database software. Well, the expected outcome for our prototype is we would like to use the DNA space to manipulate or taking care of the BLE sensor data that maybe a temperature or heartbeat or any vital sign that can come to the DNA space. And the DNA space can have the intelligence, what is the threshold and what is the next actions that are going to be due, like trigger up a RESTful call to my server to do something, like to write something to my SQL server, or trigger up a SMS using my SMS gateway. The solutions that we have, or the component that I used, I have my SQL as the backend database server. I use Python to write script for the SMS triggering. I will have a little bit more detail for the SMS in the demonstration part. And for taking care of the RESTful call from the DNA space, I use PHP to write a small pieces of program to receive the RESTful call and then write the information into the database. In order to make it happen, we have some prerequisite to meet, like we need a DNA space service. To set up the DNA space, we log into the DNA space, and then we scroll down to find access locator. Next, we have to configure a route. That route, you need a name and the descriptions. Next, you need to define a threshold. Whenever the sensor read the information, for instance, I want my temperature sensor to trigger up a actions whenever the temperature go over 30 degrees. Once it go over 30 degrees, then it will trigger up an actions. But what kind of actions do I want to do? I can do like email, I can do SMS. Actually, this SMS in the DNA space is not triggering a SMS. It just also trigger up a email as well. That's why I cannot use this one to send an SMS. Instead, I have to build my own SMS gateway. My SMS gateway is quite primitive, but in a few pages down the road, we can see how my SMS gateway is built. But anyway, I want to trigger up a RESTful call. That's why I use the HTTP as my actions. In my actions, I have to input the web link or FQDN that pointing to my web server or application server, whatever you want to call it. And in the repeat notification, I have to set it to the minimum time, like 1 minute, in order to trigger up a immediate actions. Otherwise, whenever there is a trigger, it will take some time, some delay for the trigger for the actions. The minimum that I can do is 1 minute. That means whenever the sensor sends, okay, as it's go over 30 degrees, it will trigger up a RESTful call to my application server. In order to fulfill the FQDN, I use the AWS Route 353 to manipulate my domain name setup. If the end user have the real IP address, I can use the real IP address, or alternatively, I can use the FQDN. In my situations, I use the AWS Route 53 as my name server. Here is the AWS Route 53, and I set up the FQDN here. That is simple. For my application server, I have a small pieces of code that receive the RESTful call from the DNA space. Whenever you receive the call from the DNA space, that means my sensor actually sends the temperature over 30 degrees. Once the sensor over 30 degrees, the call comes to my application server, and my application server will open up a DB connections, and then it will do like the first action it will do is, so let's start from the example. That means it lists out everything from my example table. I just want to like show something up in my screen such that I know something happened. Next, I will write something back to my database. For instance, if I want to do like write something into my database, I can code the first row, no, the first column, like the timestamp, the second column, like the temperature that I have received from the BLE sensor. But anyway, in here, for my prototype just primitively define the first column as first. The second column, I name it as second. And I just randomly put some string that, but I think I use DNA space and triggers as my parameter, and using them to put into my database. So this program is very simple. Whenever they receive a call from DNA center, it will write something to the database. Secondly, if something happened, I can like process the information that I have in the database, and I can trigger, for instance, if I have consecutively message or data or record in the database for like 38 degree, maybe a patient's got fever for more than like 3 times or 4 times. That means the patients catch fever over 3 minutes or 4 minutes. Then I can trigger up a SMS, send an SMS to a nurse or doctor to take care of the patients. So here is the logic for my SMS gateway. I have a IR809 router that have the LTE module. What I need to do is just like put in the pieces of the SIM card into the IR809 router in order to make it like a SMS gateway. Okay, I need 2 things or 2 files. The first file is the content of the message. Here, I will send to my phone number. And here is the message. DNA space trigger is the message body. And something before is the username, password, and enable. You can imagine it's just like you telnet to a router, and you have to give the username, password, and you tap enable in order to enter the enable mode. And the last one is calling to a LTE module to send an SMS to my phone. But how can I take this as an input to my telnet sessions? I use the curl command from the Linux server. So this is the syntax. I telnet to that SMS gateway or the IR809 router and pipe in the SMS text such that it's just like an engineer telnet to the router and punch in this kind of the command or CLI into the router interactively. Next, I would like to show you the demo for the SMS that triggered by the DNA space. Okay, let me show you the SMS gateway here. So whenever there will be a trigger from the DNA space, and it will send to my web server, but I don't have the actual setup in my home. That's why I cannot like heat up the sensor and trigger up a call, but I can manually to trigger up a SMS program. I have 2 files. The first file is called sms.txt, as we discussed previously. The second file is the command file, the Linux script file that calling up a curl and piping in the SMS. So I can show you the send sms.sh. Okay, this is the program that I have. Just only execute 1 line of program to send the SMS. Now, let's see what happens whenever I will trigger up a SMS. As you can see, it taking administrator and the second line, my password into the router. And then I execute the enable. In the last statement or last CLI, I trigger up a SMS, and then I have to wait for like 1 minute because the IR809 is quite slow for the SMS sending. It takes like 1 minute or even 2 minutes to send the message. So we have to wait for my phone for the message. Let's wait. Okay, I have received a message from my SMS gateway. Next, I can screen capture in my phone, and then I send a WhatsApp back to my computer. Okay, done. Okay, when I go back to the WhatsApp, and you can see, I send it back to myself. I have the SMS sent to my phone, and you can see I have a few messages here. Actually, they're the same message. The previous two are the testing message that I tried before I tapping this video. The last one is the SMS message I just trigger up and send it to my phone. Okay, thank you. This is my demonstrations for my prototype